Every second, the sun floods the solar system with light and energy, perfectly steady on human timescales. We built our entire civilization on the assumption that this light never flickers. Power grids, satellites, climate, photosynthesis, all tuned to a star that behaves like clockwork. Dozens of observatories stare at the sun every day, looking for flares, storms, and subtle changes. For decades, the sun's brightness has been almost boringly stable. But what if, just once, it dropped? Not for hours, not for minutes, for one single second. In this scenario, something inside the sun causes a brief, global drop in light output, lasting roughly 1 second. We wouldn't see it instantly. Light takes about 8 minutes to cross the space from the sun to Earth. 8 minutes later, everywhere on the sunlit side of Earth, shadows soften, daylight dims for one unnatural second. Satellites in orbit would see the entire day side lose about a third of its light and then snap back. Spacecraft solar arrays would report a sudden dip in power, like someone briefly dimmed the star itself. A few people might notice a strange dimming on a clear day. Within seconds, solar monitoring centers would see it, a clean, sharp notch in the sun's light curve. White light, ultraviolet, even X-rays, all showing the same 1 second drop. Parker Solar Probe data would be checked for any sudden change in the solar wind. Every major instrument, every continent would be time-stamped to the same second. The sun really did blink. To understand how a 1 second solar flicker could happen at all, we have to look deeper into what the sun really is. To make the sun dim even for a second, you have to disturb how energy flows from its interior to its surface. Distant stars sometimes dim for a split second when their magnetic fields collapse. The sun could do the same, a brief micro-dimming flash. Another theory involves exotic particles, axions, or dense streams of dark matter. If such a wave passed through the sun, it could briefly change how photons move through its layers, reducing brightness from the inside out. A localized gravitational ripple could momentarily compress solar plasma, changing the way light escapes before things return to normal. Tiny, temporary, but enough for a 1 second flicker. The sun constantly vibrates. A strong enough internal pulse, a helioseismic shock, could disrupt how energy flows through the photosphere, causing a brief global dimming. None of these events have ever been recorded on our own star, but physics says they're all possible. 1 second isn't long enough to destroy our power grids or freeze the oceans. Most systems would ride it out, but every satellite, every solar sensor, every spacecraft log would carry the same unexplained notch. Scientists would recheck decades of data, looking for any hint that the sun has done this before, and we simply missed it. For most people, it would be a strange story on the news. For others, the moment they realized our star isn't as simple as it looks. If a 1 second dimming ever happened for real, we'd survive it. But it would change how we think about the sun forever. Because once you've seen your star blink, even once, you can't unask the question, what else can it do? If it happened once, what stops it from happening again? 1 second solar flicker, a near-future scenario. Stay with us, subscribe and like this video.